For years, we have called the coil in the outdoor unit the condenser coil, as that designates the work this coil does. With the introduction of the heat pump in the late 70s, we started calling the coils on a split system the outdoor coil and the indoor coil, because with a heat pump, the function of the coil changes depending on what mode the heat pump is operating in. In the cooling mode, the outdoor coil functions as a condenser, and in the heating mode, the outdoor coil functions as an evaporator. So we are looking at the function of the condenser coil, or as in this depiction of the refrigerant circuit in the cooling mode, the outdoor coil. And we see that the refrigerant comes out of the compressor discharge as a hot gas or a vapor, and at that point where it enters the coil, it is high pressure. In the outdoor coil, the heat content contained in the refrigerant vapor is given off to the air that is blowing across the coil. As this heat is exchanged between the refrigerant and the ambient air, the refrigerant vapor begins to condense and changes in state to a liquid. The refrigerant condenses in the outdoor coil. The refrigerant exits the compressor discharge as a high-pressure vapor. As it moves through the coil, because of the exchange of heat from the refrigerant to the ambient air, it changes state and starts condensing into a liquid refrigerant. By the time the refrigerant reaches the last few passes of the coil, it has condensed into a liquid. This is the latent heat process where the refrigerant changes state. In the last portion of the coil, the liquid refrigerant is further cooled by removing more heat from the refrigerant, which is our subcooling, to assure that we have a solid column of liquid leaving the outdoor coil heading to our metering device. Latent heat is the energy of molecular separation and arrangement. It cannot be measured by a thermometer. It is the heat absorbed or released when a substance changes its physical state completely at a constant temperature. As we have seen, latent heat is the energy of molecular separation and arrangement, which cannot be measured by a thermometer. Heat is added until liquid boils, and as it continues to boil, the water changes state to a gas or steam. The temperature does not change, but the state does. Sensible heat is the energy of molecular motion. It can be measured with a thermometer. Here we see that the temperature has changed in the sensible heat process, but no change of state has occurred because no boiling has taken place. In this diagram, we see sensible heat being added to 32-degree water, raising its temperature to 212 degrees. Then we see the latent heat process as the 212-degree liquid boils at 212 degrees and changes state and becomes a vapor. After it becomes a 212-degree vapor, more sensible heat is added, which is our superheat. Going the other way, as heat is removed through latent heat process and the 212-degree vapor becomes 212-degree water, more sensible heat is removed and the liquid is further cooled, which is our subcooling. In order to determine the amount of subcooling occurring in the outdoor coil, we must take a temperature reading on the liquid line of the refrigerant as it exits the outdoor coil. We also need a pressure reading from the liquid line service valve access port. We then convert the pressure reading to temperature, and using our gauge or using a PT chart, the difference between the two temperatures will be our subcooling. So here we see our outdoor coil at work. We have 95-degree outside air with 120-degree saturated coil temperature. We know from the laws of thermodynamics that heat will always flow from hot to cold. So the refrigerant in our outdoor coil will give up or reject its heat to the cooler outside air. This exchange will take place as our refrigerant condenses in the outdoor coil. In order for our outdoor coil to do its job efficiently, we need to make sure our system is charged properly and we have the correct subcooling. We also need to make sure the outdoor coil is clean so the air can flow smoothly and cleanly over the fins to pick up the rejected heat. You also want to make sure there is no recirculation going on with overhangs or bushes or other units being too close to allow proper airflow over the outdoor coil.
Go to arefco.com for more videos, like, subscribe, and check back every week for new videos.